Hey guys, let's look at this problem here. The weakest condition for the initial value problem. For this initial value problem to have a unique solution. We know that to have a unique solution for this kind of initial value problem, you know that the weakest one is the ellipse is continuous. This should be ellipse is continuous with respect to y then this system has a unique solution. That is the weakest condition. If it is differentiable on the region on D, then it is fantastic. But so the question is asking the find the weakest condition for this system. The weakest condition is the ellipse is continuous with respect to y. So this is the correct answer, right? So if f is differentiable on D, then it is fantastic. So for this one, yeah, unique, yep, there exists a unique solution. Continuous, if the function is continuous, we can say that this system has a solution, not unique. If there exists a unique solution, then this has to be ellipse is continuous with respect to y. So this is the correct one. So this is the weakest or least condition should satisfy. This is the weak condition, right? So if you go to the next question, the least condition for the initial value problem here to have solution. So what is the weakest or least condition? Continuity, yeah, if that is the least condition, right? If this function is continuous, right? If this function is continuous on the domain D, right? Then the system has a solution, right? This is the weakest. If that is ellipsis, we can say the solution is unique, right? So the if this function is differentiable on the domain D, what happened? Yep, yeah, there exists a unique solution. But the question says we had so question says finding the weakest or least condition. The least condition from here is this one. If the function this function is continuous on the domain D, we can say this system has a solution, that is the weakest one. And the other one is this question. Let's look at this one. The ellipse is continuous. The function is defined on the domain here, right? X is bounded by 2 and 0 and y is unbounded. So how do you show this ellipse is continuous? So it is enough to show the derivative of f with respect to y is bounded over this region, right? So when you find the partial derivative of f with respect to y, you get 2x squared. So it is clear that we know that x is bounded by 2 and so is 0. So we know that the partial derivative of f with respect to x is bounded. Therefore, this function is ellipsis. So if you so you can prove that you can show the definition satisfies ellipsis continuous property, right? So here to find the ellipsis constant, so first find the partial derivative of this with respect to y, which is 2xy, and find the uh, infimum least value. So what is the least value infimum of that partial derivative over this region? So when you find the partial derivative of this function with respect to y, you get 2xy So you know that x is bounded by 2, then so what do you get? 2 times 2 squared, which is 8. 8 is the least upper bound for that derivative, right? So the ellipse is continuous, will take that value. So the ellipse is constant will take that value. So if for ellipse is constant would be 8. You can use the definition, right? If take 2 points in the domain on the domain, right, and show that f of x comma y less minus f of x comma y dash, no, y star, let's say y star, right, is the modulus of this less than or equal to the constant. Find this constant. You will see that it is equal to 8. The constant is is at the constant time y minus uh, y star, right? So the ellipse is constant is 8 here. So if you look at this one, this integral defined on this interval, so AB interval, and find, so this one is equal to what? All right, so you can put, so look at the terminals here. So these terminals are converted to -1 and +1. So you had to introduce a transformation. What is the transformation? We have learned this in the class. All right, this is the transformation, right? So yep, this is the relationship between t and x, and when you plug this value for x, you get the t variable varies in between -1 and +1, because this is a straight line. This is a this is the one-to-one corresponding between t and x variables, right? So yep, substitute this transformation into that, into this, you see that so dx over dt, dt over dx would be 2 over b minus a, then dt dx would be b minus a over 2 times dt. Then where's that yeah, b minus a over 2. So you can remove this solution, this one as well, so the solution would be one of these. Then check this transformation, 1/2 b minus a times t plus b plus a over t. All right, let's check that one. B plus a plus t times b minus a. This is the correct answer. To that, yep, this one would be the correct answer, right?